Hi Bobcats! In this video we're going to take our first look at the mole. Our objectives include using the mole as a counting unit, to use Avogadro's number to define the mole, and then also to successfully perform calculations with Avogadro's number. It's always frustrating to watch students who manage to set up these calculations perfectly, but then get tripped up typing them into their calculator. So we want to review how we do scientific notation on a calculator too. So the mole is the chemist's basic counting unit. It's a way that we can connect an amount of substance that's large enough to work with in the lab to what's going on at a molecular scale. The mole is often presented as a counting unit, and you're familiar with a counting unit, although you may never have thought of it in those terms. The counting unit for eggs is 12, and we call it a dozen. So 1 dozen is equivalent to 12 items, whether they're eggs or whether they're something else. When it comes to purchasing packages of paper, a ream is a standard unit for that, and that's usually 500 sheets of paper. Well, for a chemist, if we're going to get an amount of a chemical that's big enough for us to handle in lab, we're going to call that amount a mole. 1 mole is equivalent to 6.02 times 10 to the 23rd items. So that might be molecules, it might be formula units, it might be atoms. So basically, the chemist's version of a dozen is 1 mole, and it's 6.02 times 10 to the 23rd. So admittedly, Avogadro's number is a very strange number. You know, it's 6.02 times 10 to the 23rd. So why not make it 6 times 10 to the 23rd, or bump it up to 1 times 10 to the 24th? Now, why such a weird number? Well, the answer to that comes from this equivalence that we're trying to establish between what's going on at the particle level and what's going on at the lab level. So in the left-hand side of this picture, we're looking at a water molecule, and a single water molecule has a mass of about 18 atomic mass units. Imagine an experiment where we take super imaginarily small tweezers, and we move these water molecules into this beaker of water that's sitting on a scale, one at a time. So we are now transferring water molecules into the beaker one at a time. We keep doing that until the display on the scale is telling us 18 grams. So we have this correspondence between the mass of a single molecule at 18 atomic mass units and this collection of water molecules that's big enough to have a mass of 18 grams. The number of molecules that it takes in order to reach 18 grams of water is 6.02 times 10 to the 23rd molecules. That's why this very strange number came about. So this weird number, 6.02 times 10 to the 23rd, is also known as Avogadro's number. Amedeo Avogadro was an Italian scientist who did experiments with gases, among other things, and this number is named for him. If you are going to type this number into your calculator, there are good ways to do it and there are bad ways to do it. You really need to know your calculator and what's the best way for your calculator. I personally strongly prefer using the EE or the EXP key, depending on what brand of calculator, it'll have a different name. If you're looking at either a TI graphing calculator or one of the other models that's set up to mimic the graphing calculator, if you find the number 7 and then you look at the key that's above the number 7, it's got a comma on it, The second function on that key says EE, and that's what we will use for scientific notation. If you're looking at a basic scientific calculator, like the one I prefer to use, which is the next one over in these diagrams, the EE key is the key immediately above the 7, and it is the first function. It is not the second function on that key. And then on this Casio calculator that I happen to have lying around when I was taking these photos, instead of EE, the key is down at the very, very bottom, and it says EXP. Most brands other than TI use EXP for this function. So the way you type in this number into your calculator is you type in 6.02 and then you hit the EE key or EXP key followed by 23. You do not hit times, you do not hit 10. Depending on your particular make and model of calculator, the display on your calculator might say something like this, 6.02E23. I always thought this was really weird. On the display it says E, but the button you hit says EE. That's okay, that they're different. That's just the way the calculator works. On my favorite kind of calculator, this number will show up over with the power of 10 over on the far right side as a number separated from the rest of the display. The advantage of using the EE or the EXP key is that when you use that key, the 6.02 and the 10 to the 23rd are tied together as being a single number. And so if you use it, everything that I'm drawing a box around right now, the calculator treats as being just one number. If you use the other techniques that the calculators have for entering a number like this, typically the calculator divides this into two separate numbers. It thinks that 6.02 is one number and 10 to the 23rd is a separate number. And so if you aren't super, super careful about how you're typing things in, where you wanted this to be one big number, your calculator will treat these as two separate numbers, and you maybe wanted to divide by this whole number, and instead you divide by the 6.02 part and then you multiply by the 10 to the 23rd part. So it's really advantageous to use the EE or EXP key in communicating with your calculator to make sure that the calculator keeps those two numbers locked together. Just to check real quick to see if you are doing it correctly on your calculator, take a moment. You may want to pause the video, type this number in, and see what you get. All right, the correct answer is the first one, 7.19 times 10 to the minus 22. If you got any of those other answers, you are doing something that makes the calculator think that the math you want to do is something like 433 divided by 6.022 and then times 10 to the 23rd. And sometimes people come up with ways of doing this that even put in one extra times 10 into what the calculator thinks you want it to do. So that is not going to work. That's not what we want to do here. So if you're having any difficulties with this, make sure you ask me for help. This is a great thing to clear up. It takes like 60 seconds if you and I can work one-on-one to do this. Our objectives were to introduce the mole as a counting unit, to use Avogadro's number to define the mole, and to use a calculator successfully to perform calculations with Avogadro's number.